In 2026, the artificial intelligence war has fractured into two completely different realities. In the United States, tech billionaires are pouring billions into a science fiction dream, building human-like robots to take over our homes, our warehouses, and our factories. But while Silicon Valley chases a spectacle of mechanical human, the other side of the world is quietly executing a multi-billion-dollar industrial takeover. Faced with brutal environments, massive geographic isolation, and severe labor shortages, Australia completely ignored the humanoid hype. Instead, they build autonomous mega-machines and hyper-specialized AI swarms that are generating immense, real-world profit right now. Today, we expose the trillion-dollar physical AI war. We will look at the hidden engineering flaws holding back America's biggest robotics companies and discover why America's humanoid obsession might actually lose to Australia's silent, highly profitable robotic empire. To understand the global tech race in 2026, you have to look at America's ultimate ambition, the humanoid robot. The United States is betting its economic future on vision language action models, often called VLA models. This is a paradigm shift in artificial intelligence. Instead of just generating text or images, VLA models allow a robot to perceive the physical world through a unified multimodal lens, mapping visual inputs directly to physical robotic actions. The two titans of this American race are Tesla's Optimus Gen 3 and the Figure robot series. Tesla is moving so aggressively that Elon Musk has initiated the wind down of the flagship Model S and Model X vehicles. The goal is to repurpose the massive Fremont factory space in California entirely for Optimus production, targeting an eventual capacity of 1 million robots per year. The engineering going into these machines is staggering. Let's look at the Tesla Optimus Gen 3. Tesla realized that the hardest part of mimicking a human worker is the hands. In fact, nearly 50% of the robot's entire engineering complexity is located just in its hands. The Gen 3 model features an incredible 50 actuators, 25 per hand, with 11 degrees of freedom. Tesla extensively studied human biomechanics, perfectly replicating our joint angles, allowing a robot to achieve 0 to 90-degree finger flexion and a 180-degree thumb opposition. The goal is a $20,000 to $30,000 general-purpose robot capable of threading a needle, cracking an egg, or carrying heavy factory parts. Meanwhile, their main competitor, Figure, is taking a different route. Powered by a massive partnership with OpenAI, the Figure 02 robots are already deployed in real-world pilot programs at the BMW Group plant in Spartanburg, South Carolina. Standing 5'6" and weighing 132 pounds, the Figure robots are utilizing OpenAI's conversational AI to interact naturally with human workers while seamlessly handling car parts. The American philosophy is clear. Don't rebuild the world for robots. Build a generalized worker that can fit into any environment already designed for humans. But there's a fatal flaw in the American humanoid dream that nobody in Silicon Valley wants to talk about. And that flaw is physics. Despite the billions invested, these humanoids face severe real-world friction. Current battery technology means that under heavy industrial load, these robots often die after just 90 to 120 minutes of work. You cannot replace a human factory worker if your multi-million-dollar robot needs to sit on a charger every 2 hours. Furthermore, the AI models are still struggling with the chaos of reality. A robotic policy that can achieve 95% accuracy in a pristine control laboratory often plummets to just 60% reliability when faced with chaotic, unpredictable real-world lighting, shadows, and textures. America is building a spectacular sci-fi machine, but right now, it is incredibly fragile. Before we look at how Australia is capitalizing on this exact weakness to build a totally different kind of AI empire, I want to know what you think. If Tesla manages to get the price down to $20,000, would you trust a humanoid robot in your house to cook and clean, or do you think it's a massive privacy nightmare? Drop your vote in the comments below, and let's travel to the outback. Australia doesn't have the luxury of waiting for battery technology to catch up to humanoid robots. The country is vast, isolated, and facing critical labor shortages in the primary industries that keep its economy alive. So, Australia's approach to the AI revolution is entirely different. They realize you don't need a robot with legs and hands to revolutionize labor. You just need to automate the infrastructure itself. Enter the Australian mining sector, the undisputed global vanguard of autonomous heavy industry. While American startups tinker with 130-pound robots carrying boxes, companies like Rio Tinto are operating fleets of over 130 autonomous haul trucks in the harsh Pilbara region. These AI-driven behemoths navigate treacherous dirt roads 24/7, managed by a central supervisory system with 0 humans behind the wheel, and they are scaling up fast. A massive trial running through the end of 2026 aims to scale battery swap technology across a global fleet of 700 haul trucks, allowing these massive machines to run continuously without charging downtime. But the crown jewel of Australian physical AI is the $940 million Auto Haul program. IT is the world's first fully automated heavy-haul, long-distance rail network. Imagine this. A train carrying thousands of tons of iron ore, traveling across more than 1,800 kilometers of track from 16 different mines to 4 port terminals. The average journey takes 40 hours to complete, and it does it entirely on its OWN, that NO driver fatigue. No shift changes. Just pure, algorithmic efficiency generating billions of dollars in export revenue. This hyper-targeted automation is also dominating the skies. Melbourne-based Free Space Operations has recently solved a problem that global universities and leading drone manufacturers have struggled with for years: cooperative lift. They have developed technology that allows multiple heavy-lift drones to physically coordinate their flight and carry shared payloads of up to 100 kilograms. This breakthrough multiplies the lifting power of a single drone by 4 times, allowing autonomous fleets to replace manned helicopters for mineral exploration, stringing power lines, and ship-to-shore logistics. And this pragmatic approach is fundamentally rewriting how Australia grows its food. The Australian climate is incredibly unforgiving. Instead of trying to build a humanoid to pick fruit, Queensland-based SwarmFarm Robotics spent over a decade shifting the entire agricultural paradigm. They replaced massive, heavy, diesel-chugging tractors with fleets of lightweight, AI-driven autonomous robots. These swarms work collaboratively, reducing chemical usage and navigating fields with pinpoint precision to kill weeds without damaging crops. For delicate work, startups like Ripe Robotics have developed commercial prototypes that use advanced AI vision and specialized suction grippers to evaluate and harvest fragile stone fruits, like plums and peaches, without bruising them. The AI evaluates the size, color, and quality of the fruit in milliseconds before deciding to pick it. Meanwhile, companies like Carbonite are using autonomous systems to spread finely crushed basalt rock across agricultural land, a process that improves crop yields while permanently capturing atmospheric carbon dioxide. This is the Australian AI maker niche. They aren't trying to build an artificial brain from scratch. They are taking advanced reasoning AI and plugging it directly into the mud, the dirt, and the heavy machinery to solve immediate, expensive problems. So, who is winning the physical AI race in 2026? America is playing the long game. If companies like Tesla and Figure can solve the battery and reliability constraints, they will unlock a multi-trillion-dollar consumer market. A general-purpose robot in every home and factory is the ultimate economic prize, and the U.S. is currently the only nation with the capital to attempt it. But Australia is winning the present. By completely ignoring the humanoid hype, Australia has built an agile, hyper-profitable network of autonomous machines that are actively keeping their primary industries alive. The Goliath of American tech is building the future worker, but the David of Australian industry is already doing the work. The global tech race is accelerating, and the gap between these two strategies is only going to widen. Which approach do you think will dominate the global economy by 2030? The general-purpose humanoid or the hyper-specialized autonomous mega machine? Vote in the poll on our community tab right now, and make sure you subscribe to Global Tech Race so you don't miss our next deep dive into America's $500 billion AI Stargate project. Until next time, keep watching the future unfold.